You ready for it? We can do it. I got some cool animations again today, so that's kind of fun.
But is there cool sounds?
There's no cool sound. You can, Kevin, make the sounds while the animation's going. That would be great. We're talking about all this fun stuff. All right, so we talked about the fact that a node's made up of data and a link to another node. Right, so in this example, the node's data is Bob, a string, and then a link to another node, right, whose data type is like node star, or in our lab, SL node star, right, because it's a pointer to a node. Which is interesting because it itself is a what? It's a node. It can technically point to itself, but don't do that. And then, right, if you don't like my picture on the board, right, there's the other picture, right? First node points to second node, points to third node, points to null, right? To get to John, remember you have to start at where? You have to start at Bob, right? There is no direct pointer to John, right? There's no indexing with linked lists. You have to go through the list to get to where you want to go. Everyone good? We have to understand that before we can do anything else, right? This is what we're trying to create. And so now the question is, algorithmically, how do I make sure that I always create it this way? And that's what we're going to talk about today. And so there's one thing missing from this list. There's one thing missing from this list. Anyone know what it is?
The beginning?
Okay, the beginning, right? So Bob is the beginning, yeah? And the one on the board, 1 is the beginning. Agreed? So I keep saying, well, to get to 3, we have to start at 1. But is there anything that points to 1?
Nope.
No, but there needs to be, right? Because every node is dynamic, right? It's a dynamic data structure, which means there needs to be some pointer that points to this. And that pointer we call head. All right? So there's always a head pointer, and it points to the first node in the list. Okay? So every linked list, remember we're going to do it class-based. So we'll have a private data member that's called head, and head always points to the first value in the list, or if the list is empty, head points to where? Null, right? So head is null when the list is empty, and then we add nodes as we go. You notice I didn't draw it as a box, right? It is a variable, right? But I want to show the difference between a node, which is made up of multiple data points, right? A number, an arrow, a string, an arrow, versus head. Head is not a node, right? It's a pointer to a node, right? So its type is node star, right? But it's not, it doesn't store data, right? It just stores a pointer to a node. So it's a little bit different than all my other nodes. Does that make sense a little bit? So head's missing, and so, right, we want to make sure that we have that in our thing. Without head, right, we can't get to our list, and our list is ridiculous. So we do something like this, right? The head pointer of type node star points to a node, and a node is made up of, in this case, a string and a pointer of type node star, right? Because it points to there. Now I can get everywhere on my list because I can start at the beginning head, which is Bob, and get all the way down to John, and John points to where? Okay, we're going to do all this once again class-based. So I'm just going to make, right, a node star pointer in my class that, right, can then point to the first thing. We'll call it head underscore, right, because we give underscores to all of our class methods. So point beginning list, that's head, right? You don't have to keep track of it, but I think it's nice if you're going to make a class that you should keep track of the size of your list. Okay? There's a big reason why I think that's important. Okay? To know how many nodes are in a list, if I didn't keep track, what would I have to do? I have to go through all of them and count them, right? So your time complexity is going to be linear, n, right? You have to count every node, right? Follow every arrow. But to get the size of the list, I might not want to do that, right? And so it'd be better for me to just keep track of it, right? Every time I add a node to the list, just increment size by 1. Every time I remove a node from the list, just what? Decrement size by 1, right? Then you can do it as you're going, right? Which makes your algorithm slightly more complex, but at this point, if you can't do plus plus and minus minus, then we have problems, right? Okay. So it makes it slightly more complex, but then it makes the time complexity of size way better. Does that make sense? Okay. So it's optional, but I think I just told you why it's useful. And then those two things, right? Head underscore, pointer to the beginning of the list, right? Size underscore, right? The size of the list, right? Those are your private data members of your class. Make sense? Right? And remember, we don't need like size of list and capacity of the list, because what do we know about lists? Do they have capacity?
No, you can just add more.
No, you just add more, right? So there is no max capacity, right? The max capacity
It's
is
as big as the heap.
right, as big as the heap, which is quite large. All right. So the rest of the stuff, right? Those are my private data members, right? So if I have some class, right, named list, right, and inside the class I have private data, right, of node star head underscore and what? Unsigned, because we can't go negative, right? Unsigned and size underscore. And good that, that's what we just talked about, right? And so what we're going to do on the rest of our lecture today is talk about public, right? What are the behaviors that a list can do, right? Things like what? Add a node to the list, remove a node from the list, traverse the whole list, and traverse is going to every node in the list and doing something with it, deleting everything in the list, right? Clearing the list, right? All those kind of things we need to talk about, okay? Some of them we'll talk about today. Some of them we'll talk about on well, shoot, not Monday, it's Wednesday, right? Monday's a
That's right,
holiday,
we don't have school Monday, huh?
right? No school Monday. Because what?
Most happy when I heard that.
Yeah, we've had a lot of not school days this semester.
Uh,
This is not the last one though. Cross my fingers, right? This is the last planned one. All right, so let's talk about what our list looks like when we create it, right? This is a list that's been created and I've added values to it. But when my list is created, right, what happens?
takes memory from somewhere, right?
Okay, it takes memory from somewhere. But let's talk about initial state of the list, right? So let's say I make a list object. Okay, when I make a list object, I have two data points, right? Head and size. So if I make an object, right, of type list, let's call it LL for linked list, right? It has two data points, right? It has a head underscore and it has a size underscore. Are we good with that?
Mm-hmm.
And when you create an object, what runs? Constructor, good, right? The constructor runs. So the question is basically, what is the constructor supposed to do? What is the initial state of the list? What should the constructor do? And what do we think the constructor should do? What should the initial values of those two things be? That's not confusing. Right. One's null, right, and one's zero. Agreed? Right? So initial creation of my linked list, head is null and size is zero. Right? And we do that inside of the constructor. Pretty easy. Right? At this point, my list is empty. I don't have any nodes, but that's okay. Right? And so now we need to talk about, okay, how do I add to the head? I say there's two main conditions for adding to the head, right? And those conditions are either the list is what?
No.
Null, meaning empty, or there's something in the list, right? So we have to think about those two conditions, right? Either there's nothing in the list, and so I'm adding the very first node to the list, or there's already nodes in the list, and then I'm adding another node. Does that make sense? You notice this says add to the head, head being the front of the list. So when you add to the head, you're adding nodes before everything else in the list. Does that make sense? We're used to adding things to the end of arrays because shifting is a pain in the butt, right? But here we're going to add all values before all other values in the list, right? So add to head says add a node before all the other nodes. And we know that with linked lists, that's fine, right? It doesn't take a lot of time, right? Because we just update some arrows and we call it.
So we update it from the front, not the back.
From the back, from the front. We'll do the back eventually. That's tail. Go figure, right? So we have head and we have tail. All right. Right. So if the list is empty, right? What are we gonna do, right? We have to create some new node, right? Give it a value, right? We'll just give it a value. Does that make sense? Remember that right? This is where the programming gets a little difficult, because I think understanding this is not hard. But you have to remember that when I create the node, there must be some other, right, pointer to it, right? Every time you create something dynamic, you're gonna have a pointer. Does that make sense? Right? And for new node.
Could be a temp pointer, right?
Right, but it'll be temp, right? So it's gonna come into my function, it's gonna go away at the end. And the goal is when the new node pointer goes away, that my list pointers are pointing to that node. Does that make sense? So what do I need to do? I need to make sure the new node points to null, right? Because nodes themselves have what? Pointers.
Oh.
Right, so you have to make sure the new node points to null. Good news. Your SL node has a constructor. And in the constructor, what do you do with next node? It points to where? Null, right? So you set up the constructor already for it to point to null, so you don't have to do this. Right? All new nodes that you create, because you made them class-based, will always point to where? Null. As long as you wrote the right lab correctly. And then you need to make sure that head points to the new null, or to the new node. So head's pointer, because it's the first one, needs to point where? To the same place that new node is pointing to. Does that make sense? First, right, node you add to the list, you point the, right, the node to null, which is already set up, and then you point head to the new node. Okay? New node will go away because it's, right, scope goes away. And then the head pointer, which is a linked list object, points to my first node, and my first node points to where? Null. Is this a linked list? Yeah, that's a linked list. There's one thing I forgot to do.
Increase size by 1.
Right? So size needs to go up.
You just plus plus at the end of the function.
Yeah, exactly, right? Size plus plus. Pretty easy. Size underscore plus plus. Does that make sense? Let's talk about, right, when the list is not empty. Okay? So if I create a new node, right? Remember, by default, it points to where?
No.
Null. And I have a new node pointer to it. Okay? So if I want to add that to the head, okay, what needs to happen?
Where it's pointing to null, point it to the other node.
Okay, so where the new node is pointing to null, point it to where?
The other node.
The other node. The other node is always going to be pointed to by what?
Head.
By head. Because remember, I'm adding to the head. So then, if you think about it, if I'm going to add to the head, I'm going to put something new in the front of the list. The second node, which was the first node, should be pointed to by the new node. Does that make sense? So the first step, and we have to do it in that order, we need to point the new node to what head is pointing to. Point the new node to what head is pointing to. In code for you, it's new node, arrow, set, next, node. Right? And inside of that, you just say head underscore. Take the new node, set its next node, that's a mutator you wrote. Take the new node, set its next node to what head is pointing to, so we say head. And all of a sudden this arrow points to where?
The other node.
The other node. So that's step one, right? Make sure the new node points to where head is pointing to. And then what?
Have head point to that node.
Head point to the new node, right? And so then we need head's value, right? To no longer point to the old head, right? But now point to the new node. Remember, head is not a node. So you don't say set next node on it. You just say head equals what? New node, right? Head equals new node. Because you're just, right, assigning pointers, not what those pointers are, right, pointing to. You're not dealing with the object, you're dealing with just a pointer. And then what are we going to do? Last thing? How big is my list?
Oh, the size increases.
Size increases. Are there 2 nodes in my list? 1, 2, yes?
Mm-hmm.
Does head point to the first node?
Yes.
Yes. Does that node point to the next node?
Mm-hmm.
Yes, and does that node point to null? Yes. So does my linked list, and remember this will go away. Scope will say that goes away. Right? Does it look good? Does it seem right? Is that complicated? Hopefully not too bad, right? Point what? The new node to what head is pointing to, and then point head to the new node. Point the new node to what head is pointing to, and then point head to the new node. Now, I said 2 conditions, but I'm going to convince you that really it's just 1 condition. That's because when the list is empty, what? When the list is empty, head points to null. So if you say the new node points to what head is pointing to, well, the first node, head's pointing to null, so the new node's going to point to where? Null, which is fine. So it's actually the same algorithm. You don't need an if statement. You just point the new node to what head is pointing to, and then point head to the new node, and then increase size by 1.
So technically, we only need 1 function for both.
Yes, 1 function, no if statement. Okay? So here we go. Right? Empty list, we're adding the first thing to head. Right? So I need to create Darla. What my slide doesn't show is that what? That has a pointer to it, right? The new node pointer is pointing to Darla. Okay, but the algorithm says point Darla to what head is pointing to, right? Which is null. Makes sense? Point Darla to what head is pointing to, and then point head to the new node. So head's going to point to where?
Darla.
To Darla. And then what's going to happen in the corner here? List size is going to what?
Increase.
Decrement by 1. Does that make sense? Point the new node to what head is pointing to, and then point head to the new node. To point the new node to what head is pointing to, you have to use the mutator, set next node. To point head to what the new node, or to set head to the new node, you just say head equals new node. Because they share. Okay? Right? It's always funny when I add to it, right? My list looks so nice, but we know that in memory they're all over the place, right? So really they should look ugly. But here we go, same algorithm. I'm adding to the head. I'm going to point the new node to what? To what head is pointing to. So I point Darla to where? Bob. Okay, and then I point head to the new node. Head points to where? Darla. Does that look right?
Mm-hmm.
Did I have to shift anything? No, right? That's the beauty. There's no extra time complexity to add to the front of the list, right? You just create the node, update some pointers, and you're good. Make sense? Questions there? All right, that's it. That was easy, wasn't it? Right? So, removing from the head, there's also 2 conditions, right? Either the list is what? Empty, or it's not. Okay, this one actually matters, because if you try to remove a value from the head and it's empty, what should you do?
Nothing.
Good, nothing. If you try to remove a node from a list that has no nodes, you should do nothing, right? So you actually only do the remove from head when what? When head does not equal null. So when head does not equal null, that's when we do our removal. So this whole function needs an if statement, right? Say when head's not null. All right. So when the list is not empty, let's see if we can figure it out. I want to remove 1, right? What do I need to do?
Point head to the other node.
Point head to the second node,
To
basically.
second node, yeah.
Right?
The one
So
after.
point head to what head is pointing to. Doesn't that sound weird? You're going to point head to head's next node. Does that make sense? Point head to head's next node, right? And so we're saying something like this. Point head to head's next node, and then what else do we need to do?
We have to delete that first node.
And then somehow this has to go away, right? Okay, and there's some problems with that, so we're gonna get.
Does it just return to the heap?
Yeah, right. We'll just return to the heap. All right. So the list is not empty, or the list is empty. It's easy. You don't do anything, right? That's the easiest element you're gonna write. Okay. Please note this slide says problem. Right? This is what we talked about, right? Remove the node head is pointing to, point head to the new node, right? So if I remove the node that head is pointing to, if I delete head, what happens to Darla? Right? Space gets freed up. Great. So there goes Darla. What happens to my linked list?
It's just gone.
Gone. But not, or it's forgotten but not gone instead of gone, not forgotten, right? It's forgotten, but still there. Right? We got a big old memory leak going on here. Right? And that's because the only way to get to Bob was through who? Through Darla. And when I get rid of Darla, what happens?
Bob, Jane, and John don't
Yeah,
exist.
goodbye, Bob. Bob knows about Jane, Jane knows about John, but no one knows about Bob anymore. Right? So if that didn't work, let's do it the other way. Point the head to the next node, and then remove the node. Before we said remove the node and then point next. Okay. So point head to the next node in the list. So head points to Darla's next node. So head points to where? On the bottom. Okay? And then what's the problem?
You got 2 pointers pointing.
We can't find Darla anymore. At least that problem's less, right? Before I orphaned a bunch of memory, now I'm only getting rid of one. But Darla's always gonna be there. Darla still knows about Bob, but no one knows about Bob. Right? It is a little dark. So that doesn't work either. Agreed?
Mm-hmm.
How do you think we fix? What do I need?
Temp.
Some temporary pointer, right? If I can't do it with the arrows that I have, then I need more what?
Arrows.
I need more arrows, okay? And that's just a temp. So you do the same thing, except now you create a temporary pointer to where head is pointing to. So node star temp equals head, right? Node star temp equals head. So now head points to Darla and also what?
Temp.
Temp points to Darla. And then I can point the head to the next node in the list. Head points to head's what? Next node. So head points to head's next node. So head points to Bob, Bob points to Jane, Jane points to John. At this point, my linked list is okay, right? Because the first node in the list is gone, and the list works just fine. But now, is there a way to get to Darla?
Yes.
Yes, there's what?
Temp.
Right, to get rid of Darla, I just delete what? Temp. If I delete temp, then Darla goes away. What happens to temp?
It's still there.
Still there until when?
At the end of the function?
Function ends. Scope says, right, let's gobble up the pointer.
Ah.
Right, and then head points to the next node, right, or to the first node, which points to the next node, which points to the next node, which points to. No. Does that make sense? And also, what happens to list size? Decrement, right? So in the remove, size minus minus. Do that inside the if statement. That way you don't decrement size when there's nothing there to decrement. Right? Because when you decrement, right, size as 0, and you decrement it and it's an unsigned int, what happens to it? It's really big.
Oh.
Right?
Oh, that's
you can't
right.
hold negative numbers, so it just loops around to the highest value of an unsigned int. And all of a sudden
It's
you're
like 4 billion.
quite large. Yeah, 4 billion something. Not so good. So what do? Make sure the list is not empty. Right?
Mm-hmm.
If head equals null, it's empty. So if head doesn't equal null, that's when we can do my algorithm. Right? Create the temporary pointer. Right? Point the head to the next node. So head equals head next node. Right? Then what? Delete temp. Decrement size. Temp goes away with scope. And we should be good. Does that make sense? Questions there? All right. What about clearing a list? Clearing is the idea of what?
Deleting all of it.
Deleting everything in the list. Right? And if the list is empty, guess what? You don't have to do anything. It's clear. Or it's not empty. So if it is not empty, I need to what's called traverse the list. And traverse is just saying go to every node in the list. Right? So traversing a list is saying go to every node in the list and do something with it. In this case, the do something is delete it. Right? So I get rid of every node. All right? And then stop at the end, right? We can stop when what? The nodes that you're pointing to is null, right? Like it's right. All right. So the list is empty, no big deal, right? Here's the problem, right? If I try to get rid of the node head is pointing to, and then I want to go to the next node and get rid of that one, and I'll go to this one and get rid of that one, right? If I delete head, what happens to Darla?
Oh.
Because she's gone. And guess what? My list is clear. Yay. Just set head to null, right? Size to 0, I've cleared my list, right? Isn't that the easy way of doing this algorithm? But what happened?
Memory leak.
All this memory leak. So you can't just use head to delete because you need a pointer to the thing you want to delete, but you also still need a pointer to the next one.
So you have to start at the end?
No, well, we can't start at the end because which way do the arrows go?
Only one direction.
They're only one way, right? So once again, if one pointer is not good enough, what do you need? A 10 pointer, right? So you need 2 pointers.
Do you have to continue until the next node shows null? Can't you just use size?
You could, but my recommendation is to always use the pointers because it will also help you find if your pointer is screwed up.
Use size.
Exactly. So if you screwed something else up, if you follow the pointers, it should crash, right? If you just use size, they'll do it 5 times or 4 times, and maybe you'll be okay. So it'll help your error messages show up. All right, so that doesn't work. So this is what we're gonna do. We're gonna introduce an iterator, a temporary pointer, to help iterate over the list. Okay, so that's the goal, right? We're gonna create the iterator. While my iterator isn't null, that's my loop. So instead of saying, right, a for loop, do it 10 times, 8 times, that kind of stuff. We just do it until the iterator points to null, right? Because at the end, we should get all the way to the end of the list, and then the list is null, right? And inside of that, we're going to point head to the next node. We're going to delete what the iterator is pointing to, and we're going to move and catch the iterator up. And then at the very end, we'll just set size to 0. Or in the loop, you could decrement size every time too. That's not bad. So let's go through this algorithm. You'll notice that I'm giving you the algorithm, right? And your goal will be to write that in code. You just will go with it with the sorting algorithms, right? Maybe. All right, so create an iterator and point it to what head is pointing to, right? Node star iterator equals what? Head. Node star iterator, that creates my pointer. And we want to point to the same place. So I have 2. All right, and then we loop while the iterator isn't null, right? While in parentheses, right? Iterator doesn't equal null. Easy? Curly braces. Okay. Is the iterator null?
No.
No, so we're gonna what? We're gonna loop, right? In the loop, we're gonna move head forward, okay? We need to get used to how we move things. Head equals head arrow next node, paren. Head is not a node. Everyone good with that? I'm trying to stress that. Head is not a node. These are nodes. Head is just a pointer to a node. So that's why we use the assignment operator, because head is not a node, it's a pointer to a node. So it's just an arrow, and we're going to have it be assigned the arrow located in the node head is pointing to. Because let's look here again. I said head is just an arrow. Everyone go with that? Head's just an arrow. But that arrow points to a box that has a what? That has an arrow. How do I get that arrow? Next node paren. That's your accessor for the arrow. How do I get the value? I think it's like, what? Value paren. Does that make sense a little bit? Right? So if I say head equals head next node, it says head's arrow becomes head's next node's arrow. So head is technically going to point to where? Jane. That's what that line of code says. Head equals head next node. says that head points to the arrow stored in the head's node. Does that make sense? Okay, what do you think I should do now? Head's moved on.
Delete the iterator.
Delete the iterator. Right? Delete what the iterator is pointing to, but in code to delete what the iterator is pointing to, we just delete the iterator. Remember, if you delete a pointer, it doesn't delete the pointer, it deletes what the pointer is. 22. So when I say delete iterator, who goes away?
Bob.
Bob. Goodbye, Bob. All right, and then what do you think I need to do?
Loop again.
I'm going to loop again, but first,
Point to what head is pointing to.
right, iterator needs to catch up. Iterator equals head. Right? It needs to catch up. Once we're caught up, we can move head forward again. We can delete the iterator, and then the iterator can catch up. So is the iterator null?
No.
No. So point head to head next node.
Mm-hmm.
Right? Delete the
Iterator.
iterator. Goodbye, Jane. And then iterator equals head. Right? Catch the iterator up. I know, my algorithm just said set it to 0 at the end. If you do it correctly, it'll be fine. But you could decrement size each time in a loop. Right? Is the iterator null?
No.
No. So head equals what?
The next node.
Head next node, which happens to be what?
No.
No. Okay, but that's fine. Nothing wrong with that, right? Delete what?
Iterator.
Iterator. And then iterator equals head. So iterator in this case points to where?
No.
No. And then we loop on what?
Well, it isn't.
It
null.
isn't null, and guess what?
It is.
It is. So my loop what?
Ends.
Right, and then we can set list size to 0. Does that make sense? Right? While the iterator isn't null, we loop, and in that loop we move head forward, we delete iterator, and then iterator catches up. Right? I mean, you can technically do it the other way where you move iterator forward, delete head, head catches up. It doesn't really matter. Right? But I would just do it the way that I told you to do it. What does a destructor do?
Frees up the memory.
Frees up memory, right? It's the, okay, my object is going away, get rid of any dynamic stuff that it created, right? My object is my linked list, so anything dynamic in the linked list that got created, we should get rid of, right, when the object goes away. Does that make sense? Right? The algorithm to do that is the clear algorithm, right? The algorithm to free up all memory in my linked list is this clear algorithm that we just wrote. That makes sense? But sometimes you want to do it, right? Not when we're at the end, but just sometime I want to clear the list. But we also need the destructor to clear the list as well. So in the destructor, I can just call the clear function, right? And it'll take care of everything.
Just to be 100% sure, so when you dynamically created this on the next node and the contents are both dynamically created?
Yeah, well, because they're internal to that.
Yeah, they're private parts of it.
Yeah, exactly. So in your destructor, it's just call the clear functions, clear paren, good to go. That's all your destructor needs to do. You don't need to rewrite it, right? It's already created. Even if you haven't written it yet, right? Right, the destructor with clear, and then eventually write the clear. So clear took traversal and deletion and combined them, right? But you also might want traversal in itself, right? Traversal is go to a node, do something with the node, go to the next node, do something with the node, go to the next node. Right? A lot of times those are like output, right? Create my toString, right? It could be like add the values of all the nodes together, right? Traverse, right? We do this with arrays all the time, right? Arrays is easy though, right? Int I equals 0, I less than size, I plus plus, right? We do that with arrays. Linked list, because we're with pointers, we really traverse while some pointer isn't null. Because when the pointer is null, I've reached the end, okay? And to do that, we just follow our links, right? Move down the list, right? To next node, to next node, to next node. So to get from one node to the next node, I have to follow the pointer in that node, right? To get from one node to the next node, I just follow the pointer, right? So follow the arrows, right? So I could, right? Okay, head's pointing to Bob, so I get head's contents. right? And then I can say head equals head next node, right? What we wrote here, head equals head next node, and this arrow moves which way? Forward to Jane, and then I get head contents again. And then head equals head next node, right? I get head contents, it's John. And then I get head's next node, it points to null, and my loop could end, right? The problem with this is what? What? Ruins the list, right? So I can't really move head. The way I really move head is when I'm adding a node, I'm deleting a node, or I'm deleting all the nodes.
You need another
right?
temp, right?
I just want to see all of them, right? I need some temp pointer. And that's the thing that should move, right? So once again, we have this idea of an iterator, right? So I want to create an iterator pointing to the beginning and use that to iterate over my list.
And you just say iterator next node.
Yeah. So node star equals, or node star iterator equals head, right? And then while the iterator is in what?
No.
Null. So while the iterator is in null, we'll do something with iterator's contents. And then we'll say iterator equals iterator next node, right? Move it down the list. It's always what it is equals itself next node. So while the iterator is in null, right? I say do whatever you want with the current node. Output it, add it to a string, add it to some other values, right? Do whatever you want with that node. And then when you're done with that, move your iterator to the next node. Iterator equals iterator's next node. Right? In this case, we don't want to mess with that. Right? So it moves down. Right? While the iterator is in null, guess what? We keep doing it. Right? Output Jane, and then iterator equals what? Iterator next node. Iterator's not empty, so what? Output John, and then iterator equals iterator's next node. Right? And then, right, while the iterator is a null, but this time it's what?
It's null now.
So that was pretty easy, right? One for loop, while the iterator doesn't equal null, right? Do something with the iterator's contents, and then go from there. Does that make sense a little bit? Let's talk, that's the last one for here, for today's lecture, but I want to talk a little bit about the mutators and accessors that you have with your node. Right? Because the node that I had to create, right, was of type SL node. Right, that was our lab on Monday. Okay, SL node is made up of next node underscore and I think contents. That sound right?
Yes.
Right? And so contents can be, I think we're doing integers, so that could be some value, and this could be that. Right? If I want to get that value, the accessor is called next node paren. If I want to change the arrow, right, it's set next node. And the paren some pointer. Does that make sense a little bit? Right? Content, same thing, right? I have a contents paren that gets the value, right? And I have set contents, right? Some number, right? And that's going to change the contents. Okay? So when I want to deal with the arrow and the node, meaning if I want to deal with Bob's arrow or Jane's arrow or John's arrow, okay, if I want to deal with any of those because they're inside the node, I need to use next node to get the value, or I need to use what? Set next node to change the value. Does that make sense? When I'm working with data inside my node, I need to use these functions. Next node, set next node. If I want to change Bob, right, then I need to deal with contents to get Bob's value, or set contents to change Bob's value. Okay? So these functions are used when you want to change anything about the box, the node. Does that make sense? You do not use these functions when you want to change these arrows. Because these arrows are not nodes.
They're just pointers.
They're just pointers. So if I want to change head, I would say head equals something. I don't say head arrow next node equals something, right? It's just head equals something because head is a pointer. Iterator is a what? A pointer, which is why we say things like head equals head's next node. Head is just a pointer, but I want that pointer to point to the same place as that pointer. Well, that pointer's in a box, so I have to use my next node function to get it. Does that make sense? Everyone see the distinction between the two? And that's why up here when I said new node, arrow, set next node to head. Because when I created new nodes, I wanted to change the arrow in the node. To change the arrow in the node, I have to use what? Set next node. To change anything about the box, I need to use my mutators and my accessors. To change pointers that are not nodes, I just use the equal sign, right? Assignment. So, right, as you write these algorithms, you have to ask yourself, is it just a pointer? So I use the equal sign for assignment. Or is the arrow inside a box? And then I need to use either, right, next node, set next node, contents, right, set contents. Does that make sense a little bit? All right. So you should have created your node on Monday, right? And you can use then that node, you're gonna have to copy that file over to the next, right, to today's lab, and then start writing your list. And when you get those done, right, then on Wednesday of next week, we'll add more to it. And I think there's one more.
Cumulative.
And then a midterm. So that's what we got planned. That sounds like fun. Oh, and you have an assignment too.
Yeah.
Right? Which you guys already figured that out. Right?
Just starting it?
Yeah, I hope you're not just starting it. That's a little scary to me.
Just starting it, I won't let you down.
You know, I normally think if I give an assignment that, right, and I assign it for 4 weeks, that I think that'll take you maybe like 3 hours.
You give us 4 weeks to brace for that 3 hours.
Right, exactly,
I
right?
would say you spend those 3 hours.
I really hope you're not just. But it's not gonna hurt me. I'm not the one who's got to stay up late and freak out and stress out and use error.
No, I value my sleep more than that.
Yeah,
So,
right. I just take it 0. It's not like assignments are that big of a deal.
yeah, it's fine. There's only 5. That's not
Yeah,
that important.
yeah, not bad. 5 on to like 30, 40% of your grade. No big deal.
Oh,
No
jeez.
big deal.
The phones got a lot smaller after.
Yeah, after the outages, that is true. But I guess you left out of that one. Who needs a UI anymore? I will say this too, on Canvas, not only did I give you the PDFs, but it's kind of fun if you open up the PDFs because there's animations in my slides. You get arrows pointing everywhere. You get all the arrows all at one time, right? Because it'll just show like all of the stuff.
Yeah, you just can't click through it. It just automatically there.
Right, they're just all there. So I also gave you the PowerPoint on Canvas. So if you want to click through it, right, you can look at that as well. So that might be helpful. Just realize that the PDFs are great for the algorithm part of it, but not for the visual part of it. The visual part of it will look like iterator points everywhere. It'll look like head points everywhere, which is not actually what's happening. So just be aware. I'll even put up the first algorithm. Good? You guys good? I mean, maybe you're not good, but I can stop talking around. Can you get your eyes up and then you can go through?
Oh, yeah, please.
All right. Oh.
Yeah, that's not sufficient. But, yeah. Well, okay, I'm sorry, yeah, you're right. Yeah, no, so you have this backwards. Your size should be null, your capacity should be 25. Yeah. Your size is how much stuff is in there, capacity. So, that's what
It's just to meet like those two variables on to do the exact same thing.
Did you use underscores for your size?
Looking at the variables.
That is actually
This type of player should be to do items first on.
Well, that's the type of it. So your list should be a slash star.
I can change this to do items first star.
Well, that's just the definition type.
Oh.
Yeah, no, you had that right.
Okay.
Yeah, put that back. It's so think of this as like int, right? That's the type. So like int capacity. This is to I'm sorry, star list. Well, I would go list right after that because that's the type, and then now you're naming the type, which is like exactly. So now list is a pointer to the list of pointers.
I still don't understand pointers.
His idea with the errors helps us.
And this is like on to do for the deconstruction.
I think you need more time, because you're gonna have to do Oh, you need a lot more of that. Yeah, so the idea is, let's do that one. You talking about the deconstruction?
So you're just getting.
I'm not doing deconstruction. Yeah, I did. I've got to do my Destructor. Or wait. I'm not one for it.
Use reconstruction.
Yeah, I know. I thought maybe I could. Yeah, no, you're right. I never actually created.
I just read like the instructions and reason to do items.
Yeah, so yeah, you basically delete the pointer, which is, doesn't delete the pointer, it deletes what's contained, what the pointer points to, and then you assign the pointer to something else. So you delete the pointer, and you right underneath that. No. I think the item was the start. I think that's a kind of type, not a variable. You see what I'm saying? I know. Trust me. This is a. I don't think he's basically saying that whatever variable you have named types you can. And you can declare that. You want to know
I'm going to talk about adding a new item to the pointer to the array. That's what I understood.
Yeah. The add, I believe, is passed on to the array.
Yeah.
Delete actually has a location for that array. So you have to cross
You probably just do this one is set
right here where let's see if we can tell that group practice. Yeah.
my eyes are like,
Yeah.
anyways, so I think it's later.
Sorry, not just being fine. Arrow, again, some. I'm trying to
jump right up.
understand this, so edge, size, to do item, this, arrow, size, flip,
Right, so yeah, you're basically your error checking is now so you just make sure, you choose the size of the same capacity. If it is, that means it's full, right? So you wrote something like that. So basically, that's a little tricky, but it's similar to what you're doing up here. I've created a second class, which was really just a pointer.
That's more effective, implement, size, not to be, 25 is no longer be, no.
Right, that happens out here, but that's the last little thing basically. So basically, list 2 gets created inside this function, which goes away when it's done, right? But I assign it a pointer, a new list with basically pack cat plus, that's the size of it. And then for int while I was on the size, it works. Basically your copy, so it starts off with location 0. Copy location 0 from the first list, text out 25, so it takes in the same spot, which is now plus. And then once that finishes, which is basically size, that is one less the size, then you put list like that, then you assign the original list, the address, the new bigger list you just made, and then you create your cat by 10, and then when this function ends, that list 2 gets completely removed together. Your new list has a.
So list 2 is essentially like a 10.
Correct, exactly. In fact, it's probably, I should probably. So it's easier.
Right, now I'm back if you want to.
Okay.
Hope you let me know when.
Yeah. Wait, about, okay, yeah, actually, I agree. So like, my first issue is saying that this is not being repaired.
Yeah, if I could, I did ask. That's fine.
Oh.
I think I said it in ampersand too, out loud. When I wrote that.
Yeah, I was wondering why that wasn't working.
It should be. They're really bad at writing. It's stupid. I got it. I'll do it now. You can do it. You only get like the first.
Oh, I see.
So this is the first thing, like error to do item has not been declared. So that says it's to-do list.h. So it could be that your to-do list.h doesn't include the to-do item. That's what Kevin was saying. Right? If we think about it, the to-do list is made of to-do items. So if it doesn't know about to-do items, then right, your type. It's all freaked out. So these have return types, but this one has return types, these don't.
I'm supposed to.
Well, right? What is it?
Well, I'm sorry, you should.
That's fine.
Oh, you're going
Alright, so it's fixture boards, I'll come back.
Okay.
I think there's like 3 more there.
Just about all of them will have a board, right?
All the ones that don't have return types. So the ones, some of them already did have return types.
Let me go back to the lab here. 17. Okay. Now, for some reason, I'm failing one test. Failing the overloaded constructor.
So in here, set contents to that, but then also set next node to null.
So I have to do that still in the parameters here?
No, just. All right. So one one's coming in, and the other one just set to default. So
Okay.
say next node equals next node underscore equals.
Okay, let me try that.
And that should do it. Yeah,
I gotta make it, yeah.
You can say make. For the lab, you can say make. Yeah.
No, you're right, yeah.
No matching function for the call. Oh, I must have moved some stuff around in the H file. Yeah. Wait.
Could you,
No, all I did was change that. Oh, it's trying to read from the.
But if you look,
test.
so there's 2, but if you go back to your other one, I think there were 3. Oh, no. 1, 2.
And it's telling me the candidate.
It could be because I think you did you do default arguments? You did them on this side, they should be on the other side.
Oh, I should set the default arguments on the H file?
Mm-hmm.
Okay.
And I want to say. It's in the other order, but maybe not.
I think you might be right.
Int param. Oh no, because there's so the int parameters first. The default sets to null and that. So if you want to do one, that's fine, but you should do it
in reversed order.
Oh, so I should do the contents first,
Mhm.
and then the pointer.
Yeah, and then you don't even need this one. Because now that one will handle
I
everything
don't
for
even
you.
need the overloaded structure anymore.
Yeah. Because now with the defaults, you've actually written a bunch of them, right?
Yeah.
So in here, you switch these around. Don't need the null anymore.
And I don't even need the overloaded constructor.
And now you don't need this one. Because that one will do everything, right? If they pass in nothing, contents will be 0, next node will be null. When they pass in contents, next node will be null. So it should be.
Do these have to be in a different order, or does it?
Yeah, that order doesn't matter because that's in your function.
Okay. Now another question.
Okay.
I gotta go back
Mm-hmm.
to assignments.
Or, well, sorry, I named the choice, but that
I'm
location.
gonna try to make to-do list.
Because
Finish code.
the first,
And then I gotta do like 2 and then head. And then I get in to-do item. It is not been declared.
No, it's in to-do list.
Oh, it's in to-do list.
So in your to-do list H, did you include to-do item H?
Oh, I gotta do it.
Yeah.
Oh, Yeah.
So after S stream, so after like the library includes, then you want to include your
Yeah, I gotta include the other H file.
yeah to-do item dot H.
That's probably why it's
That's why it says.
freaking out.
That's why it doesn't know, right? Every place that you said to-do item in your whole.
Yeah.
Oh, yeah?
I basically, yeah, I just, you have to shift, but. As long as choice is less than, equal to size, right, it's not bigger than size. It's not into one of the rules slots. Then it'll allow the two to have root list and the choice on this one. Yeah, and then you have to shift.
What's the E? Which one? Oh, is that the,
Shifter is the one that just moved.
I use that. What's the compact way?
Yeah, I don't say name the shifter. But yeah, I mean, that's probably.
No, the item's on your
Shifter, for me, I'm actually positive this is how it works, but I put my shifter in it, so I pass in the choice. And basically, that's where I start the shifter. That probably actually makes sense.
So this is not how it starts.
I have a lot of other issues. I don't know.
Yeah, but that's not anything yet, so So, list is a type to do item. Star stuff. That's all I've actually done so far, right? Now your constructor, when it says create item, whatever. This is to point to an array of to-do item. So list equals new to-do item star bracket. That's all the create that for. Right? Which does this. And then later in your code, right, in add item, you'll be creating a to-do item. Right, and pointing the first thing to that. And then later on, you'll create another to-do item. So that happens in add item. So the constructor, right, here you just say, because I'm going to start star. And then you assess like size to, you have like a size variable too, then set size to 0 and set capacity. Like those are the other two.
What is this like item? Somehow, this term, the scrub function, I wasn't really sure. You probably need to put add sign.
Right.
Scrub sign scrubs the add sign.
No, the scrub only scrubs the description.
because it's description, @ priority, @ to these guys. But if the description has an @ in it, then we'll just do the @. So the start function just takes the description and gives everything @. Yeah, like here, what kind of like this thing here. You have direct access to it. Yeah, but you're you file as part of the class, we have access to all of it. And same thing here, you have access to it.
So then I just pass it my variables.
Yeah, whenever you get access, so you're passing that, and it's moving through it, and when it finds that symbol, it gets to the class.
Because our district generally is I just put it in there.
Right, that's fine, it's a placeholder. And so here, where you say, oh, this is. That's what you.
For sure.
Let me get a little more. I knew I was gonna get my exercise today. Well, no for loop or remove head, don't remove one head. So. Yes.
Oh,
Right?
I meant, but then I got my head to replace, then I got that to create my.
I think it's gonna come like a normal run, right? I think it's set. Oh, man, I've never had more people. It's still brand new.
Yeah.
Recently,
Okay, we got it.
just,
Create my.
just received those.
Right, exactly, right? So create a temporary pointer where head is. Well, head is of type what?
It's a cleaner.
It's type.
Yeah,
Over time, they'll, yeah.
or I don't know, yeah.
So if we want to create another pointer and point to the same place head is pointing to, we can do the same time. So here.
Okay, then you know, finance reading instructions.
Which is what's making the 10. And we know for sure that, right, head's not null, so it is pointing to something, right?
Yeah.
Right, and then point the head to the next on the list. Head equals head next node. So head equals one to our bottom. Right, so that's good. These increment size will allow to do that. So then the question is, what's next to do? Move the left.
I find what I do, I wake up, I hit my cup, and then
So then.
I'll literally just let it sit for about an hour. I will.
Well, if you set temp equal to null, and this arrow that's pointing to dark, that's what's in null, the dark is just, how do we do this? Right here.
Okay. Or what?
Right.
Yeah.
So now, temporary pointer to what the head's pointing to, move head down the list, delete the thing that was the old head, right, which is 10, and then decrement section.
Okay. This one, the insert head that I did, the next node is what was from the previous assignment. I'm trying to remember what was from the previous.
That's why I wrote it on the board.
Okay, and then for here, I have, for my H and my CPP, I have to include, I have to both of the lists, or what's the nodes, the SL.
So you just include, your SL list.h includes SL node.h, obviously, we never include some.
Okay.
Never include some. Right, so this one, right, adding the head, point the new node to where head is pointing to. So, I set it to what head is pointing to. Head to the side. So that's all good, except for the fact that you'll notice that insert head does not give you a node. What does it give you? Let's head.
Okay.
Right, so you have to create the dynamic taking.
Well,
You have to create right node or SL node star right new node equals something, right? Right, and And then here you would say, segments,
Oh, wait. So this, I have to equal some of the next word file.
Oh, so this is.
well, so you have to create Darla, right? So that's what this is saying. Here's a pointer that will point to Darla. Now Darla's value is actually, right? Right. We're gonna create a new node with content. And that new node is going to point to the next node. So all this code down here is going to this code down, right? I create that it's not very sure yet. That's the constructor for a node that takes
Or I
that's
change
the contents of the node.
Oh. So can I?
Correct, yeah. If it's a choice of the person's entering, yes, that's.
That's not one Yeah, so again, my guess is, so all of these, so constructors don't need return types, but everything else does. So like your add item, so this destroy list has a return type, but all of these are missing return types. And it looks like maybe a thing. Yeah, so that's all everything. So like this add item have like it doesn't talk about anything that's returning, so it would be void. Whereas like this, like get item, subscribe, it says returns, but this function will return a pointer to the new item requested. Right? So that says that like get items like will be like add item. And that's all it returns. And that's what
I didn't know they needed, I thought it was like, if it's not void, then it's.
right, just leave it. Yeah, there you go. So they'll all have something. Mobile definition. So the CVP should always include their H's, and like the Unix will should include node H or not. That one should just be SL. Okay, because temp right now is just a pointer. You're missing. So you have a constructor that will construct an SL node and also take it. Otherwise, it's here. You create a pointer which points to garbage, and you're saying take that garbage, treat that garbage as a node, and set some values in
Lou,
Yes.
do you know the grade on 15?
I think I've only graded through, what was 15?
The sorting one?
That was the second sorting.
Oh, that's extra credit.
Yeah, that's extra credit one.
Oh, what? Oh,
Yeah.
okay.
So I'm up through 14.
Which I think is all caught up technically. So, that feels pretty good to me.
Oh, I see.
Yeah, 15 session credit, you didn't have to do it, but, if you do it, then we got extra.
I was, doing a, part of the assignment where I have to use like a sort function,
Yeah.
and I was trying to look at my stuff for,
So you have
sort.
14.
Yeah.
And my recommendation is just use functions. Yeah. Well, that one. Just steal what we done.
I tried. It's still like. So, that's why I guess it's.
Lost the cost.
Yeah, and that's important, because if you think about it, when you make copies of
I just realized I added that concept over.
But it's important because if you don't do it by reference, and you make a copy of a to-do list, it actually won't have all of the values you created, because it'll just make the default constructor, right, but it won't do.
It won't have any of the guts of the one you want.
And there is something called a copy constructor, which will you can basically write code to say, okay, if you make a copy of this, also copy all of this.
Yeah, or if you haven't included like IO stream yet or something like that.
And also needs a using statement.
std::A string.
Yeah, do you have IOStream, you said, right?
IO stream will bring it in, but then I need a using string.
If you use IOStream, do you have to use, is it pointless to use IOStream? No, okay. Then you still want to use it.
Using std::A It will kind of work. The difference is that.
Using arrays around the corners.
Well, arrays is fine, but you're still in the array, you still have all your things in there. But the thing is that what you're comparing is not the array value, but a value inside of like the array.
Yeah.
So you have to say, the array at the arrow. You don't use the accessor or priority.
And I just did the same for.
Yeah, for that other one, yeah. Wait. So now you do the string, but in this case, I'm not in trouble. Okay. Wow.
Oh. Yeah. Wait, no.
Well, if we don't, how many things are you moving in?
One. Okay.
So, iterator points to head. Right? While the iterator doesn't equal null, head points to the next one, done. That equals what you have. So we, what the iterator points to, yeah, it's one of them. So when you say iterator arrow next node, it says the object that iterator is pointing to is something. What happens to the object that iterator is pointing to?
Oh, I didn't.
Yeah, that's the iterator arrow.
Oh,
It says iterate points to the next node, but it doesn't say, you can't do that, you can delete it, right? I.e. where left.
And then,
Just head.
oh,
If you
different,
point at head's next node, then it just.
right, oh,
Because you've already moved.
and then I'm still confused on that. I guess I'm like,
Well, what am I creating? Well, it's pretty easy to look at, okay, if the pointer is SL node star, then what am I creating? The pointer is
a dynamic.
A dynamic star. Well, if this was int star, then I would say new int. So it's not int star, what is it?
Pointer. Oh, so you just put Excel, okay, yeah.
No, but we want that node to be, have its context, right? When we're looking at node, right, look here, right here, look, there's SL node, same thing we just wrote. What does it take in? It takes in an integer.
Yeah.
So in the same way over here, we can say len, and we'll put it in that would be a calculation.
Oh,
That's it, correct?
right,
So here's your
okay.
parameter, an integer came in, got stored in content, now you're going to do that's all
Yeah. And then for the instructions, we have, stuff, I don't have this. What is it?
Police chief.
That's just, that's a
Not
accessor.
changed anyway.
Remember, accessors are named after what they're accessing, so that's just for inside of it.
Oh, and I said, for, with the copy that I'll do with the teacher, sorry. Okay.
So that's the
I don't know, ignore that copy.
This.
But this right
The
here, you know
real.
what I'm saying?
So it's similar to clearance if you're not deleting.
Oh, this is out this, yeah.
I do believe it has to be connected to What it is, it has the pointer to the left. So that's all you're, I use. Nope, because, that's built in. The priority.
That's what we told you.
Oh. Yeah, well, I think I was just kind of guessing that.
No, I think it's
So,
the
that's just-
I didn't think about it, it's like, I didn't know, it's an automatic deletion.
Yeah, I'm probably gonna have to rewrite this entire. You're right, I wasn't sure what I would do. I just kind of copied it, set up.
Oh, because you didn't do an underscore?
I think that is the swap value for it. Like maybe to cut some.
I think it would work. I know what I mean, I just need to make sure it's running off of the, that part of the item. I need to make sure it's only running off of the priority. So instead of doing the whole item, let's do.
Oh, well, okay, so go to set contents.
Well, I'll be sorry, but now I'm not.
This next one should be your accessor. You have a set next
Yes.
You should have a next node function. You should have a set next node function. With that one, this one.
So I'm just looking for the term. Oh, so you take this function for ends, and then it will be evaluated.
If you look at it, this one, but you say that's the this one was a lot of it. It was nothing I did.
Because it will read that until it's false, and then it's going to continue to be something false. So it will make that screen.
It ended up being much better online.
Oh, so.
This one. I got it. Biggest true.
Break a new one. Once the new ones in your head, and break a new one. Oh, yeah, sorry.
No, we haven't written this size. We'll do that and then I can take out. Yeah, now it's probably say that's fine. Yeah, that's the thing in 27. Okay. Yeah.
Not.
Okay. Although it could just be really something. That's usually what before, right? What I'm gonna do is, because you have a set point, right? And so you can just, because you have a set point, you can just, because you have a point for last node, so you don't have to loop, you could say, tails, next node points to the new node. And then tails goes to so then, time stuff to the top edge if you want to. That, you use the right again, so the only difference though is that then you don't have to introduce here. This is your first node, right? So we can marry this into because then that introduces tail, and then as you add more things to the head, tail still comes yeah, all of a sudden they're like, the world is ending. Pointer. What? Come close.
And should this be a swing stream?
Yes, it should.
Okay,
So.
Yeah, no, see, I just.
okay.
Yes.
So just kind of have a hard time understanding the file
Okay.
function.
So
So,
two files.
so we're using string string, right? Are you saying that we should output each individual to be either in the array?
So move through the array, right? And then for each spot in the array, output, remember, each to-do item has its own to file. So you just call the to file for each to-do item, but not a lot the application.
Alright, And I was just making sure I understood it because we had similar main function in the previous one.
So this one, the to-do list will use the to-do items for each individual.
Alright, thank you.
Moving the other one, right? So that's why you want to copy it. Well, I mean, look at that. There was a no, and okay, so 10 should start. I don't think should start. The first thing, no, the title would be no, the function would be no.
Oh, no, as long as the resolution part is different, so it's basically like if you're using like file for it, so it's like, list dot file, it's different from item. So it's like, but those are the same things.
We will do that. That's what you're at. You will do that. Because add item says if there's room in the list, add the item. There's not, add the item. The action capacity. Should have a right. Add item should have a pointer. So as a plan. So item star. So that's the thing you want to have to put, guys. Item you want to put on the list at.
So inside this function, we actually all of it.
The constructor creates it. Let's create it. So you have this, basically. This is where you're at with all that item. Regardless of if you have things in it or not, right? And the big thing here is that there's two things. There's your size now. So this is where you're at. So add item gets called, right? And basically you have a new one item, right? And it points to a to-do item. So when the function gets called right now, this function these three data points. Right. Exactly. And then here's the parameter, right? So I've already created this. That's what I passed in. Like I basically passed in the point. Yeah. So this is what you have. Items the pointer points to the item. Your goal is to add this to the next spot. Now,
I should check for the next one.
you can, but that's a waste because first spot is at location. Okay. Yeah. This is at location. One. Right. So where am I adding that right now? Location one. Two. That's what I have over here.
So I should add
Because when I do that one, when I add in the current size, this will point here.
Oh, no.
What happens to the size?
No.
And now the next available spot's up.
Oh, yeah.
You don't need a loop, you just say, my list, bracket, size, equals, so you know where it is, right? This thing tells you the next spot. So long as these things are not.
This is the structure.
Right. We already have it, so you just say list. List is your list. I would say list square bracket. You do that so long as size and capacity are equal, it's full, and that's where you
Yeah,
can
I think so.
Yeah.
Come on, like that.
That's almost kind of what I really don't know.
It's just not, it's
It's because I know you don't have your SL list. That's fine.
Oh, okay.
It's in this one.
Yeah. There you go.
Oh.
One there, one there. There. But you will, right?
Yeah.
I'm done using for the semester. I remember that about 2/3 of the semester. I got policies.
Why just change it back to that?
Yeah, that should be a double stack again.
It is a to-do item, right?
But then in there and that should be a stack.
Oh, this one starting?
Show your array is made up of 2. Right? 2 stars point to 1 stars, 1 star point to 2. Otherwise, that would make an array of 25 to-do items that would allocate all 25 right now. That's not what we do.
I see. This I just really kind of confused on.
I mean, you could do it like that, right? Number of arrays are always a little less than some, it's always too far. You're saying one space, two file over the list.
Well, I guess when people.
Which works, it's just ugly. If you think about it, the two files is just like description, at, and then a number, at whatever.
So what would be, I would have to look at the description.
For mine, I would put a little header on top. I see out of description. Because then like completed status, you're not gonna put 0 and 1, but it's only people. Right, you got like yes or
So.
no. That would you leave it like this for now.
So you don't want to use 2 file at all.
Not in that one. So it's like,
So would that be,
so in here, you would just do something like,
to get one of those two with the arrow and the description on each one?
this, at I, arrow. But because you don't have access to it, you're not going to do it by right, you're not going to do it by, you have to access it.
Ah, right, okay.
And then you can just set up the output however you want. Okay.
Well, well, so for the shifter, basically you need something to know where to start.
So it's saying that this list can point to, it has a pointer in it, that points to an accessor. Yeah. So you think about it, I went through all that, like, the list has to have an X. If
You're going from like
the
say
list
class,
you
you only have 4, right?
I start.
You want to read like.
We're going to start at no.
Basically, you're starting at 3, to the 4 sticker slot, have a null to that 4 spot, null to that spot, and all the way to the end. So, yeah, but if you go to.
They're on the desktop, but they're good for you. It's like eating your Wheaties.
I think.
There's no sugar on these Wheaties. It's like eating that shredded wheat before you're like,
I just back because the one I'm using is somewhere up here. Yeah, they're in order. That's just the last thing I put on.
Include string strings, you can actually do.
And then,
It starts off at the spot you want to get rid of, and the shop is the one next to it on top of it. Okay. I mean, that effectively deletes it.
Pair member in read only object.
Oh, you're right. I do need to delete. You're right. I do need to delete. Because that whole item in that spot's still there. I'm missing my delete. This just takes care of what you
It says you're moving head. Remember constant.
Actually, you know what? I did.
So you're in 2
This is
strings
just
with
a
traverse
part of it. If you go up to my
So
actual
head should not move.
deal, I think I did.
Because you should traverse your list, but head should always be one of the list.
So delete
And this is the
the
same.
list at the last one, and then perform the shifter twice, which shrinks it, and then decrement your size. So that's what Max will do.
You may be iterator.
yeah.
I just put it in, yeah, I just made the shifter part also.
Because you already pointed at the head, right? If you moved it first, then you're not at the head point, you're not at the. Now you're doing better. Killing you today. Sometimes it's good for you.
Oh, you guys, he's like.
The 2 string looks like you're outputting pointers. And you should be funding what the homeowner is. And then we ask that thing down.
No, not good.
Work out. They're always good, right? No, they're bad? So this should be like iterator contents.
Oh, in parentheses, after. With the loop?
Well, last year, we talked about that. Here, I mean, it's constant. Let's talk about this. So create an iterator point ahead, so head and iterator point in the same place, right? If there's something there, then it's not gonna be null, so we're good, right? And then you're saying, okay, we're gonna output the contents, so what an iterator is pointing to, and then you're gonna say the iterator is gonna point to heads next.
Oh, I see, yeah. You have to get your count.
The next time iterator points to heads next. I had that removed. So iterator is always pointing to heads next, the second thing.
Right.
Right, what do you mean by iterator, which one is the bottom first, the second time iterator is going to only have next node, which is James, and on the next one, iterator is going to block. On the next iterator is going to block.
Yes.
So we have next node, is like.
No, sorry, it's not.
It's like moving, right, and this one.
2 underscores.
Right?
Right.
No, just like reset percent, and then put it in. So that's what you want to type.
Big on it.
Oh, God. Yeah.
Oh, this has it.
Is there not a solution as well?
No, there is, but they're not going to come at the end. So how do you do it, right?
Yeah, so how do you take that figure?
Okay.
To do is.
Well, this comment,
Arrow.
But you don't want to go to the last one.
Oh, man. No, okay, so except for the last one.
Right. How do you know it's the last one? Remember, we wrote it was the check, right? So I can check that it don't add to the file if I'm at the last one. Like if where I'm at, this next node is what?
Arrow and one. Is that? I can't put that.
So one, that's a pipe, so shift this button.
I wasn't sure if that was part of it or not.
Yeah.
Okay.
So there's a space in between one of the pipes.
Right. Cat plus 10, whatever yours is called.
9 function, and then shift off the function. Get item is supposed to be a 2 new item star. Yeah, I'm sorry, I didn't say get item. It was add item, delete item, or voids. Sort. That's the should get a sort. That's the way. Your 2 new rows, so that plus 10, and then the shift there about voids as well.
Is there any like dates or?
Yeah, there's a lot. So get size of capacity are both unsigned in. Get item is 2 item star. Those are both unsigned in. Yeah.
So you started big, and then you said stop when I, right? Oh, wow, we should get sorted.
Is this is supposed to be
That is, so that type is 2 new item slot. To return name of form.
So this is expanding. Is that all right?
That's not right. I'll go ahead and do that. That's not.
But it's trying to sort.
So that could be, I think it should be listed.
So the only thing is that you have to set.
Yeah, but the problem is, that's like a declaration, so that's like just saying int with no variable. So you need to name the variable.
Oh.
Well, so you think about it, this is a blueprint, so we don't have the values in the blueprint. The values.
So writing the constructor.
Yeah.
So I'm gonna start following, so this is just, the Destructor. When I'm making the notes,
So this time, that is how many you hold, that is how many are currently on. Here, you have to say size. That makes sense?
yeah, to teach one of the.
I have 5 spots in this array on the board, but I only have 3. So I don't want to go to cap, I can't delete this.
Yeah.
And then I'm checking the I index for size.
Okay.
And that's why I was figure out just size of it.
What is that history?
I was trying to find, here, something.
Oh, we already have, it was just, it's just size.
So what I just do this, and then in the bracket size, equals size.
Make it out, and it gets that value.
How do I look for that?
So this is what you're really trying to say, is like, right? It's in size. It's flat. When the size of your list is smaller than how many,
And then this is kind of
that's one thing that, although that was supposed to be, I don't know. So then, but that only adds capacity and we still do this. So I'd say that's
So I should make that a function for non-capacity when
Yeah. And then really, this code gets easier because it's not if size is less than that, if size is greater than equals that, you just say decrease cap. And that's the end of the if statement, and you always add, so when you put the 2 lines of list that size equals height. Thought I was done with you. I used to think you already.
I'm still trying to get rid of it.
So the hint, trying to give you is that you always have the contents, and now I'm saying that there should be some if statement that says that
First
you
one,
only output
the
that.
first one should be done, second one needs to be a stable.
Right?
First one is like, are they equal? Yes. The second one is.
So I wanna say next node. is what-
Who's next then?
Iterator.
Okay, so it's iterators.
A lot of times, the first one is bottom
So
of
you're saying that when the iterator's next node is null, that's what I think. Yeah.
I don't know.
Okay. When there was only one, you would get 1 comma. When there were 2, you get 1 and 10 commas. So it's only added a comma on the left. On the last one. Because you said that when you said this says if this current node is the last one, add a comma. I'm saying if iterators next node is null, add a comma. That's how you right, so you want it when the iterator is not the last one.
It's not the last.
How do we say not? Right?
Right.
When the iterator's next node
right.
does not equal null, add a comma, right? Okay, let's just look at this. While iterators next node not null, add a comma. James next node not a null. John's next node is null, don't add.
Okay.
And we're doing while doesn't equal.
This while is so good.
Well, in fact, see, it's in assignment,
While we're not at the end. So we move while we're not at the end, but then there is a check if I'm almost at the end. Right? Really, if I'm not almost at the end.
No.
I got my.
Oh, okay.
I actually got my return.
Yeah.
My function return
Yeah.
is way off. Like, yeah, I had to make unsigned in, so make one void. So, I'm wondering if I can help you.
So I wrote the whole thing, and so right now,
I only studied.
yeah, I did it all, so.
I got mine in compile. I didn't write it.
So your items is called.
Yeah, I wrote all of that crap, and then I was like, hey, let's try and compile it. Yeah,
This is the point, this is the type, right? And then, right, this is int, right? This is int.
I don't think
And
I
then we
did
just
the
bring
right
that
function
to
correctly,
call
but I
it
just kind of
item.
put in some of
What is
the.
that?
Or I don't know if it's working
Let me
perfectly, to
check,
be
yeah,
honest.
you're like trying to figure out that. So int,
At least for now.
yeah.
I'll have to see actual full.
Well, no, that's return type. That's return type.
I just.
This will work, it'll just be a crap, so as of right now, I just want to try and get the file.
What if I, it should be now. But you might
I get
get
a
a
message
message
to say that I was missing your return type, do not have a return type. It could be either your value file. Oh, yeah, you don't have any return types in your .h file. That might be the problem.
Probably. If there's nothing there, it's no, otherwise you're returning a list after that. List is your array. The array is an array of pointers, which will return to the item pointer. Yeah, there's
So you
yeah,
print the first 10 lines?
right. But there's no item. But item exists in that item, but doesn't exist anywhere else. Anywhere else you mark it.
Has that anything to do with array pointer, right?
No, it's not.
I thought you just make a pointer and then that's what array is.
Yeah, but technically,
Yeah, that's what
it's an array of pointers.
And it was telling me that was.
Dang.
I'll figure that maybe not. Maybe. Items.
Yeah, no. Yeah, I need to adjust that as well.
This should be, yeah.
I just-
Might work. Because you're making a pointer.
So-
It's like star now?
Right, but if you go to your to-do
Is
list.
that how you make a star?
So here,
Or you do a type star and then an array, which is.
It's back, yeah, but backwards. So yeah, you start off star, and that points to a single star, and a single star points to an actual.
And then it's always
It has a star, it's not
yeah, because.
So yeah, and this is still a pointer, and this is pointing. Or this is
I have no idea what it's doing.
pointing to a
You
list.
know, I went to read it, but then you wrote something else and it's like, I don't know what it's doing. I write it there. Now you gotta put it back in.
New underscore
I
item.
wrote it, right? Exactly.
Okay. So I just got this over. In fact, I need to adjust this so we can access my items by parts and actually only work off of orders. So this would work as long as I make that.
This one, right, so you have to remember that.
It's when we.
You have to remember that what you have, basically every
It was
function.
14.
So you would say your list, bracket J.
All it does is
So your list of bracket J.
array of numbers, so as long as you make it so it's an array of priorities from, the private component of items.
Right.
So what, I just have to.
Right, so if you did.
When you say
This is a function.
I know, but what member function?
This, you would actually be comparing
What member function?
I have my
Yeah, like when
array
you're looking at the assignment.
of pointers, right?
Sorry.
This points to two items, this points to two items.
Which is
Right.
lab for you.
If you,
Ideally, probably should have done.
just leave the algorithm like we were doing before,
Right,
we're
right,
comparing
right,
it.
different sort.
Then basically, you're saying, is this memory address arrow and this memory address arrow, what,
Because it was.
right, which one's priority,
That's what I'm
or
trying to
not,
do.
right,
That's
swap.
what's,
That's not what we're doing, we wanna say, this is priority swap, right? So each of these are to-do items, right? And each to-do item has priority and it has, like, completed and all that kind of stuff. And they have functions that go,
Comment
right?
out.
So priority has, right, set priority,
And then comment.
right, and the get priority, which is set priority,
But that's a little bit more work.
right?
So what you might wanna do is.
So then,
Another, like make a
right,
copy.
in your function, you're not gonna compare pointer and pointer, you want to compare priorities of what.
And then rewrite it with only the functions without any content, and then you just copy over those in that copy file back in. If you want to do that. Because it's just a mess, because you have all this stuff in the functions that might.
Priorities of the objects as you list.
I've actually not done a lot of it. There was a lot of
That makes
issues.
sense?
Yeah. I remember that you said something like this.
Yeah.
And then now.
I think they're return type.
Because you swap the pointers are what you swap, but you swap them based on the comparison
It is
of priorities.
It's like sort of.
That makes sense, all right?
You mean just running away?
It's a void return.
It is, yeah. It just, it takes.
Now we see what it is to.
Oh, for the goals.
Yeah.
starting
Because it might be trying to return it.
So that's definitely my issue. Is it the return? But what I need. So that's what I need to do. I need to have in this one reference, this one reference.
So where did you make the array at?
What's that?
Where did you make the array object?
Because both.
It's created
Ed is a pointer.
Well, the new one, that's to-do list, is an array.
Oh, because you didn't change it.
No, no, no. But I just really made my where it is.
So you just change them around and then reference the one that you made already, and then see if that works.
Pretty much. Not yet.
Hey, how's it going? Okay, for the.
Only then where you get items from return prices. But, saying
I'll just do your sales stuff.
No, this looks right. It's your class looks right. We'll probably write something out.
Yeah, no, I noticed that all your other functions are.
Yeah, always write up kind of what we're doing, that just lets me know kind of what we're.
I'm just calling this.
I think I have one other thing that's also right.
So I'm probably gonna put you guys.
Normally we
Yeah, it's just. It's just.
So all monetary, the two.
I think that's where I.
At least I can get, I can see what I can.
Exactly, right?
Yeah.
I think I did 2 do items.
Do you know Tim?
I don't know.
Long hair, or,
I don't
I
know.
don't know if your guys have that process. I think he's my head.
Okay.
who wants help?
Yeah, I did that. Forget item, that's what I did.
Just say it's not.
Yeah,
Yeah, I realize
When you just return 25, then it works, yeah, that's fine. If size is greater than 0, return the table of contents. That's right, so.
You list of H. You
Right?
said to do item star, hit item.
Everything else is
Doesn't do that here. So the two things that I would look at is that
Item, H, and
insert
H.
tail.
Yeah.
You should also introduce
To-do list,
that.
H.
Like, in fact, insert tail when the size is less than,
SS
right, if it's
But
things null,
hashtag
you
include
should just call.
to do item dot H. Yeah.
Right, easy.
Oh,
So
okay.
does that make sense?
Doing this.
Yeah, yeah, and remember, in that one, we introduced the tail pointer as well, so.
That's why I can't
Yeah.
find.
So, yeah, you should just call that.
Yeah.
That's it.
Yeah.
You don't have to do it that size.
But no, I don't think you need the second
You'll
one.
take care of it. Let something else do all the work, that's what I say. Do that, see if that fixes
Thank
it.
you, dude.
If not, then.
Alright.
Cry about it. Yeah,
Exactly.
exactly. I should help you anyways, yeah, hey. I wanna encourage people to.
Watch.
Wait,
Watch.
is it in that file? Yeah, I mean, you did the same thing in the CBP.
I mean, just in case like some people were talking, you didn't know it works. I've had times where I've heard something and I swear it worked, and I've heard it in.
Yeah, it's all there.
Witness.
Witness. I see a 53 out of 53.
Yeah.
I don't know if you actually wrote the program or if you just wrote a unit test that looks like it passes the program. How do you do that? There you go, good answer, good answer. You can just look at what the unit test wants and then just return if, right, return this, else if, right, already here, right? I mean, I could write a unit, I could write something that would pass the unit test pretty easily.
That's in the file.
And I'm obviously having to use.
Yeah, probably, yeah.
Or maybe it's
I'm
not
trying to
this.
make it.
Like B should be
I think that-
Ray, J, arrow.
Yeah, well, I mean, I have.
Priority.
I haven't done that, but I mean, I'm just.
No, I would do it all as since you're going to anyways. Then you're not worried about stuff moving around.
So I really only need to use it. Well, I figured it shouldn't be that bad hard, but beginning with steps right is what I think is missing yet, but I
I'm
figured
just happy that
that should work though, because I'm working with the priority.
49.
Yeah, if you just change the priority or whatever.
Yeah. If I just make
It should be okay. But just paste that into,
No, it says online.
you should be able to just paste that into the sort function. That's what the right sort function is.
That one needs a second.
And the sort function is a pass through. Just, I like that. I just write like that. You can use all that same code, but just write it in.
Oh, okay.
Oh, that's in the H cloud. Oh, you need a semicolon at the end of the class. Right there. You need a semicolon at the end of the class.
It says next note, say something now. Next note should be.
Yeah, simple stuff.
Yeah.
Oh, the other class.
Move it down. And then the iterator points to
Now,
the
yeah.
I believe the times of power went out, school was canceled.
Redefinition of your class. We do the same for class. Did you define the class?
You're in to-do list. So you have access to your private stuff, but you don't have access to private. So that just means you just use the accessors. I try to make it easy, the accessors are named after what, right? So it's like, let's just make this easy for us. And then the iterator moves down. So that's good. You're gonna get a column in your statement.
The reason why.
Oh.
It just could get here, you don't want it, but that should give you 90. Thank you.
That's our base declaration.
Oh, yeah, you're supposed to work.
Oh, you know how you changed the .h file and it was loaded? Or maybe you did it right there, you have to change the h file too. Because you made that one lower
No.
fast. No. I mean,
Yeah, you probably did, that's why. This must have done anything to it. Yeah, yours would just be,
Choose, what do you want to do? Options 1, 2, 3, 4, 5, you know, and the recommendation I give to people is you're just implementing all the functions you just wrote. The functions are the hard part. You're just making a menu. So there's not a lot of logic to what you're doing. Don't start rewriting like deleting nodes or that kind of stuff, right? Don't do any of that kind of stuff. And if you have a problem implementing the functions, just look at the unit test. That's what I did in the unit test.
yeah, he says you read.
Oh, there says my unit test, my list is not dynamic, so everything's dot, item, dot this.
Oh, does that mean in the h file?
What if I make a use item and every time the user wants to use a portion of the
You
code?
didn't write anything?
No, right? What would you like to do? Add item, 1. Sorry, that function is not available at this
Wait till the
time.
next update.
2, that function is not available at this time.
Yeah,
That's gonna be your accessory.
Well, that's just that's making a pointer to a pointer. But, does it say it's having that error? To do item?
We don't, in my classes, I just name them after the code, so it's hurry underscore.
Go to the, to do item.
As you go through.
These equal signs, because you've already defined different movies. That's why it says there's a redefinition. So delete equals false. Delete.
And then you're gonna swap them. Yeah, so then,
I need to.
yeah, you just write this.
Copy and paste.
Go to the item swap. To do item star, temp equals.
You're supposed to only define
Right,
it in
right, whatever.
Yeah, and I should know that.
A
Go to the to-do list,
Okay,
.cpp and cp.
No, but now you're just swapping the items. So,
Right, well,
so not 2 stars, 1 star. You're swapping,
I guess what I'm saying is that the list is being passed through by reference, I'm not gonna return anything.
no, you're not gonna return it, but you're swapping like, you're swapping these 2 items.